Now, if we want to find the inverse sine of the cosine of an angle measure, as long as the inverse is on the outside, work this inside out first. So work out what is the cosine of 2 pi over 3. All right, work that out like we did in the very beginning of trig. And so the way that we would work that out, we'd say we'd have to figure out where's the angle measure located. 2 pi over 3 is going to be in the second quadrant. So we'd want to figure out if it's positive or negative when we work it out. And so only sine and cosecant are positive in the second quadrant. So this, when I work this out in here, it's going to give me a negative. All right, and to work this out, to me, the easiest thing is to figure out the reference angle. So the way we would do that is we would say pi minus theta equals 2 pi over 3. Solve for theta. So you get negative theta equals negative pi over 3. Divide both sides by negative 1, you get theta equals pi over 3. Kind of a shortcut though, if you see a 3 down here, and this isn't, as long as this is a common angle measure, a 3 in the denominator should probably just be associated with pi over 3. Kind of speeds things up. Now if this angle measure here isn't common, then you couldn't do that. But if it is a common angle measure or a multiple of common angle measure, then you can just use that association. Alright, so why did I do all that? I did all that because now if I find the cosine of pi over 3 and then make my answer negative, I've worked the inside. So the cosine of pi over 3 is a positive 1/2. But since we're in the second quadrant, it needs to be negative. So when you work that inside, you get negative 1/2. So now the problem becomes the inverse sine of negative 1/2. Now we need to follow our rules for working this out like we did in the previous problems. We're taking the inverse sine of a negative. So what does that mean? That means that if we're taking the inverse sine of a negative, I want my answer to be between negative pi over 2 and 0. That's in the fourth quadrant. The easiest way to do that would be to find the answer in the first quadrant and then make the angle measure negative. So I say to myself, the sine of what is a positive 1/2? The sine of pi over 6 is a positive 1/2. Make that angle measure negative. This is negative pi over 6. Alright, let's look at the next problem. The tangent of 3 pi over 4 is on the inside. The inverse cosine is on the outside. Since the inverse is on the outside, work the inside first. Okay, 3 pi over 4 is in the second quadrant again. So I'll say pi minus theta equals 3 pi over 4. Solve for theta, and you'll get that theta is equal to pi over 4. Now, in the second quadrant, tangent is negative. So if I take the tangent of 3 pi over 4, it's going to be the same thing as the tangent of pi over 4, except it's going to be negative. So the tangent of pi over 4 is 1. So the tangent of 3 pi over 4 is negative 1. So it's going to leave me with the inverse cosine of negative 1. Now remember, if you're taking the inverse sine or cosine of 0, 1, or negative 1, then it's one of those quadrantal angles. So we have to say to ourselves, the cosine of what is negative 1? That will be the cosine of pi. That's negative 1. The answer here is pi. Alright, so as long as the inverse is on the outside, work the inside and then take the inverse of that. Remembering where the inverse is defined is important. Alright, now what if the inverse is on the inside? So let's say that I had the tangent of inverse sine of negative square root of 3 over 2. Now, as long as this is a common value that will give me a common angle measure, you could just take the inverse sine of that and then work out the tangent of that. The problem is What if this is something in here that's not associated with a common angle? Well, we could still work it out. We'd work it out by saying, okay, what does this mean? The inverse sine of negative square root of 3 over 2. That means that the sine of some angle measure is equal to a negative square root of 3 over 2. Now, in terms of x, y, and r, sine is y over r. So that would mean that y equals a negative square root of 3, and r equals a positive 2. R stands for radius, so it will always be positive. So if there's a negative in your problem, it always goes with the numerator, which will either be y or x. Alright, now, where is this angle measure located for the answer of this? Well, remember, inverse sine is defined between negative pi over 2 and pi over 2. So since inverse sine is defined between negative pi over 2 and pi over 2, if we take the inverse sine of a negative, we want the answer from the fourth quadrant. Now, I'm not going to find that answer. I just want to know what quadrant am I in. That's so I'll know if my x's are positive or negative, and if my y's are positive or negative. Well, we've already showed up here the y was negative. I just want to know, whenever I solve for x, do I make it positive or do I make it negative? Well, since I'm in the fourth quadrant, because I'm taking the inverse sine of a negative, the x needs to be positive. Okay? And so that's what I'm going to do now, is solve for x. You say, why are you solving for x? Well, we want to know the tangent of whatever that is. And we all know that the tangent of theta is y over x. So I was given y, roundabout way I was given y. Now I want to figure out the x so that I can figure out the answer. How do I do that? I use the formula x squared plus y squared equals r squared. I don't know x, but I do know y, and I do know r. So x squared plus negative square root of 3 squared equals 2 squared. So x squared is going to be plus 3 equals 4. So subtract 3 from both sides. You get x squared equals 1. Take the square root of both sides. X equals plus or minus 1, because the square root of 1 is 1. Now, since we're in the fourth quadrant, x is going to have to be positive. So x is a positive 1. X is a positive 1. To find the tangent, I need y divided by x. Y was a negative square root of 3. X was a positive 1. So the answer is negative square root of 3.